Space rocks are old observers to our nearby planet group. NASA went over a space rock and found something totally unforeseen. Space rocks are strange objects. They are observers to the beginning of life, yet they can also wipe out our civilization in an instant. What might occur if one of these heavenly bodies were to slam into Earth? Would we truly be able to defend ourselves, or are our governments lulling us into a misguided sense of security to prevent the unfathomable? NASA launched the DART mission for the first time, and humanity succeeded in pushing a space rock off its course. With this success, NASA has left a mark on history. The course of a space rock was intentionally changed so that we have any hope of saving our species in a crisis. If a space rock a few kilometers wide were to strike Earth, a huge piece of the planet would be destroyed within an extremely short time frame. Major damage and the opening of the Earth's crust would totally change the rest of the planet in the following hours and days, and we humans could possibly be history. Exactly that happened millions of years ago with the impact of the Chicxulub space rock. The dinosaurs vanished from the Earth forever. Mankind must do something if it doesn't want to be wiped off the face of the Earth one day, just like the dinosaurs. The next big space rock will come. That at least is clearly evident. In the face of this harsh certainty, we must all use our innovative abilities to build a functioning asteroid defense system. A dozen tests from global space agencies and countries have already visited space rocks. The Japanese Hayabusa mission gave historic data and even samples from the asteroid Itokawa between 2003 and 2010. NASA's OSIRIS-RX mission gathered samples from the asteroid Bennu in 2016 and is currently en route to Apophis, quite possibly one of the most dangerous asteroids to date. ESA is also heavily involved in asteroid and comet research. The Rosetta probe reached the comet 67P/Churyumov-Gerasimenko and even delivered a lander there. DART was the highlight of the mission so far. The probe slammed directly into the surface of the asteroid Dimorphos and pushed it out of its orbit. Music. DART, the trailblazer of asteroid defense, sounds like a science fiction scenario. A massive probe on a direct course to an asteroid to change the fate of humankind. NASA's Double Asteroid Redirection Test, DART, mission did just that. It might sound a bit over the top, but this test could indeed save our lives. The threat is not inevitable, but it could happen quicker than we realize. If an asteroid shows up unexpectedly, we might have only a few hours to prepare. DART replacements might one day save our lives. The lessons gained from the scientific accuracy and mechanical development of this mission are now history and one of the foundations of our asteroid defense. Why is this mission so significant, and what unexpected insights did the impact with Dimorphos reveal? The story of DART shows us in a surprising way how limited the line between danger and defense can be. The path of the Double Asteroid Redirection Test was clear. The expensive probe was built to be destroyed. The asteroid Dimorphos was the target, and obviously, DART was never expected to return. The mission was launched on November 24, 2021, at 1:20 a.m. local time from Space Launch Complex 4 at the Vandenberg Space Force Base in California. The mission type was formally Planetary Defense by a kinetic impact. In plain language, this meant that the DART probe was to impact the asteroid's moon, Dimorphos, in the Didymos system, by a direct impact in such a way that it would be pushed out of its orbit. In a crisis, this would be the best strategy for defense. The reason this technique is considered the best by experts is simply that only a kinetic impact can change the course of an asteroid so precisely and controllably, without increasing the risks. In contrast, blowing up an asteroid could cause us more problems than solutions. The explosion could break the asteroid into many smaller pieces, and these still highly dangerous fragments could then rush toward Earth. An alternative solution in a crisis is to tow asteroids using probes. In this approach, one or more space probes would dock with the asteroid and slowly pull it out of the impact path through continuous thrust. This technique is also theoretically effective, but it would require incredibly precise calculations and long-term planning to actually be successful. What is certain is that, if it comes down to it, we must redirect potentially hazardous objects so they don't hit Earth. Fortunately, this could be accomplished with just a few meters. The earlier we detect the asteroid or comet, the easier it is to change its orbit with little effort, so it can no longer pose a threat to us. DART was so successful that, for the first time, the orbit of an asteroid was successfully altered by a kinetic impact, giving us hope that we might be protected in the event of a real threat. Impact successful. A 100-meter-high cloud of dust and debris. It was almost completely silent at NASA when DART slammed into Dimorphos at a speed of 6.6 kilometers per second. Scientists and governments around the world were involved in witnessing the miracle themselves. Initially, No one knew if the impact had truly achieved what was expected. A 100-meter-high haze of debris obscured the view of DART's camera, which was filming until right before the impact. But at the moment of impact, the image was interrupted to record the collision. The LACIA Cube test, launched in 2022, accompanied the spacecraft to this extraordinary event. The Italian Space Agency had contributed the test to record the impact, even after DART had already been smashed into 1,000 pieces. The test filmed the entire impact from a safe distance. The pictures show the 100-meter-high dust storm and debris from the impact, in which the probe crashed into the surface at a speed of around 22,000 kilometers per hour. Initially, it whirled up so much material that the entire asteroid became invisible. Pressure remained high in NASA's control room for a while. The only thing that was certain was that DART had hit the target. However, the importance of hitting its target with an accuracy of a few meters shouldn't be underestimated. Thanks to data from LACIA Cube and the many telescopes that observed the impact from Earth, the incredible results were soon revealed. After thorough analysis, it was clear that the kinetic impact had altered Dimorpho's orbit far more than initially planned. The asteroid's moon's orbital period was shortened by precisely 33 minutes and 15 seconds. It was clear that this mission was not just a complete success, but would form the basis of our planetary defense systems moving forward. Up until now, data from the Italian test continues to provide significant insights that help scientists better understand the dynamics and effects of such impacts. To fully exploit the mission, another probe will be launched in the fall of 2026 to visit Dimorphos and its parent asteroid Didymos. This mission is being coordinated by ESA and will gather detailed information on the internal structures of the asteroids. A lander will examine the impact site in detail and record changes in the asteroid's tracks and chemical composition. How much time would we have in an emergency? Unfortunately, in the past decade, 2 asteroids have appeared suddenly and caused damage that could not have been anticipated. The interesting thing about smaller asteroids is their size. With an estimated diameter of a few meters, they often remain invisible even to the best telescopes. One such asteroid exploded over the Russian city of Chelyabinsk, destroying thousands of windows with its shockwave. Many people who rushed to the windows at the sudden noise were injured. The explosion caused severe cuts, and many houses were damaged. This asteroid was only a few meters in size, but still caused extreme damage. Imagine what an asteroid the size of a house or a football stadium could do. The Chicxulub asteroid that wiped out the dinosaurs around 66 million years ago probably had a diameter of around 15 kilometers. When such a chunk of rock races through Earth's atmosphere and strikes the Earth's surface with a thunderous impact, the effects are world-destroying. The Chicxulub comet hit the ocean, which slowed it down a bit, but the impact triggered a massive tsunami that traveled around the entire globe. The time we have in the event of an asteroid impact depends critically on the size, speed, and distance of the celestial body. Larger asteroids can be detected years or even decades in advance if their orbits are known. However, the truth remains sobering. Experts estimate that only about 40% of near-Earth objects with diameters larger than 140 meters are currently catalogued. These objects could be pulled out of their known orbits and on a collision course with Earth at any time by gravitational shifts within the solar system. The object Oumuamua was also a disturbing warning. The approximately 1 km wide object, which has not yet been identified in more detail, only attracted the attention of astronomers when it passed close to Earth. Oumuamua was so elusive because it emitted no light. The rock could have struck Earth. Its travel distance of around 24 million kilometers is ridiculously small in a cosmic setting. What if we had discovered an object of this size only hours or a few days before impact? The time we would have left would be so minimal that disaster would be inevitable. Will Apophis destroy humankind? Anyone who names an asteroid after the Egyptian god of chaos and destruction knows exactly what they are dealing with. The asteroid, officially named 99942 Apophis, was first spotted by an observatory in Arizona on June 19, 2004, and quickly became the conversations about Apophis have changed a few times since its discovery. Is this asteroid the next one to raise a ruckus around town, or not? After its revelation in 2004, astronomers calculated a 1 in 37 chance that Apophis could crash into Earth on its next flyby, on April 13, 2029. This number caused concern worldwide. Apophis has a width of around 340 meters and an estimated mass of 27 million tons. An impact would release an energy of 12,200 megatons of dynamite, enough to obliterate a whole landmass and cause massive damage globally. As further observations were made, The orbital calculations and the risk of an impact in 2029 were eventually ruled out. However, it is clear that Apophis 2029 flyby will pass extraordinarily close to Earth. It will come within about 31,000 kilometers, which is closer than many satellites. If Apophis passes through a critical area of about 600 meters in width, its orbit could be altered in such a way that an impact might occur just 7 years later. In 2021, NASA provided updated calculations, and the likelihood of an impact in the next 100 years was finally ruled out. Apophis was removed from the warning list, but it remains under observation. We now have a probe on its way to Apophis. In a few years, the OSIRIS-RX mission will bring rock samples from Apophis back to Earth so that we are prepared in case of an emergency. Knowing the exact structure of the asteroid will help in designing a dart-like probe to push the asteroid out of a collision path in time. During Apophis flyby in 2029, several space agencies will launch missions to study the asteroid in detail. Subscribe now and don't miss any new videos.